Modern vehicles are awash with electronics and computer controls, which means a healthy charging system is vital for the reliable operation of many onboard systems. Hi, I'm Hatto. In this module, I'm going to show you how to diagnose and test for faults in the charging system, whether it's a traditional non-ECU controlled system or a more modern smart charging setup. Before we get testing, let's re-familiarise ourselves with the main components we're dealing with. On a traditional charging system, we have the alternator, a battery, the wiring, and the drive belt. Don't forget the charge indicator light on the dashboard too. More modern smart charging systems will add an electronic control module that uses pulse width modulation to control the rotor field strength. A smart alternator will also include a current sensor, otherwise known as an electronic battery sensor, and in some cases, an overrunning alternator pulley. A fault with any of these components will result in either an undercharging or an overcharging problem, which will require you to perform an effective diagnosis and repair. Right, let's get started. It's always prudent to begin with a visual inspection of the charging system before you continue to more detailed testing. Checking the operation of the charge lamp is a must. Switch the ignition on and you should see the charge lamp illuminate. If it's not, you may have a blown fuse. Now start the engine. If the battery voltage and the alternator output voltage are equal on either side of the lamp, then the charging system is working effectively and the charge light will go out. However, as soon as a difference in voltage on either side of the lamp develops, the lamp will illuminate. On a traditional alternator, a dimly lit lamp is usually the sign of faulty diodes or a problem with the regulator, whilst a fully lit lamp indicates a no charge situation. An intermittent light is usually the sign of worn brushes. Next, you need to inspect the drive belt for any wear, alignment issues, abnormal noises and poor tension. Something as basic as a loose belt can cause an undercharging problem. If the alternator is fitted with an OAP, make sure you check the operation of the pulley. A seized OAP can lead to excessive noise, vibration and harshness and excessive belt wear. Alternatively, if the OAP freewheels in both directions, it can lead to a no charge situation. Finally, run the charging system with all the vehicle accessories active and listen for any grinding noises, which indicates a worn bearing. Also listen for any hissing or whistling noises. If you disconnect the alternator wiring plug and the noise disappears, it's very likely a fault in the alternator diodes. Now let's turn to the battery. While a flat battery is a common occurrence, too often I've seen the battery replaced on the assumption it's worn out, only to find out it's a symptom of a broader issue with the charging system. Nevertheless, always perform a health check on the battery as part of a charging system inspection. Regardless of how you test the battery, you need to make sure it's at least 3/4 charged, or it'll fail the load test. Also actually check that the battery meets the vehicle specifications, particularly if the vehicle is fitted with stop-start, as these require an AGM or an EFB type battery to handle the high load. Be aware that some of these later model cars need the battery registered into the vehicle using a scan tool after replacement. And finally, make sure the battery itself is clean and has tight terminals. If you notice any signs of bulging on the sides or spot dampness on the battery top or vent area, then you may have an overcharging problem. Now let's move on to testing the charging system itself. If you're dealing with a smart charging system, it's best practice to plug in a scan tool and check for DTCs. Smart charging systems use a current sensor to monitor current flow both in and out of the battery in order to determine the required charge rate. Any faults within the charging system should log a DTC, with or without activating the malfunction indicator lamp. Here's a good example. This vehicle has logged a P0621 code, which indicates a generator lamp L control circuit malfunction. In this case, I'll need to refer to a wiring diagram to solve the problem. I can see here I should have fused battery power to the S terminal. Power from the ignition fuse is fed to the charge lamp, then down to the L terminal. With the engine running, I should see opposing voltage out of the L terminal to extinguish the charge lamp. At the C terminal, I should see a PWM signal like this, which is powering the rotor field circuit. I had no power at the S terminal, so it's a quick fix, as I only have to replace the Alt-S 7.5 amp fuse. A quick word of caution on accessory wiring. You'll need to make sure that any accessories are wired through the current sensor and not straight to the battery post. Otherwise, you'll have unmonitored current. For a non-ECU controlled charging system that cannot be diagnosed using a scan tool, a charge rate test is a good indication of how the system is performing. To do this, place your voltmeter across the battery posts with the engine running. You should have between 14 and 14.5 volts. If your reading is lower than 14, check the output at the alternator. If everything's okay there, you have a voltage drop. If you have no charge at all, check the fuses and wiring. Undercharging problems are most common, which could be a loose drive belt, a faulty regulator or alternator. Overcharging problems are typical of a faulty regulator, a battery with a bad cell, or a bad electronic battery sensor. Be aware that performing a charge rate test on a smart charging system can produce confusing results, as the voltage can vary between 13.5 or up to 16 volts for short periods of time. As a result, using your scan tool to diagnose these systems is recommended. When it comes to performing a voltage drop test, however, you can perform the same test on a traditional or a smart charging system. Maximum voltage drop will occur with maximum current flow, so with the engine running, turn on all the accessories. To check the live side, connect your positive voltmeter lead to the alternator output and the negative lead to the battery post. Ideally, you wouldn't like to see more than 0.2 of a volt, but if you had 0.4 or higher, you need to pinpoint the problem and repair. To test the earth side, check between the alternator case and the negative battery post. You shouldn't have more than 0.2 of a volt. The final test we'll discuss is the AC leakage test. Modern vehicles require a good, clean, stable power supply. So while AC leakage from the diodes wasn't an issue on the older vehicles, it's certainly worth testing on the late model ones. A scope is a great way to quickly check the diodes by testing the alternator ripple. With the scope connected to the alternator output terminal and earth, and the system loaded, I should have a good clean ripple like this. For your reference, here are some examples of faulty patterns. Alternatively, if you don't have a scope handy, you can use a multimeter, but it must be a true RMS meter for accurate results. Just set your meter to AC volts, place the red lead on the alternator output and the black lead on the negative battery terminal or a good earth. For testing, you will need the engine running with all the accessories on. Ideally, you should see no more than 0.2 of a volt AC, though technically a maximum 0.5 is permissible. If your vehicle fails the alternator test due to faulty diodes, then you have the option of either replacing the rectifier assembly or, depending on cost, the entire alternator. Be aware, when it comes to choosing a new alternator, you get what you pay for. In summary, the simple test procedures I've run through today will help you diagnose and repair a vehicle's charging system quickly and efficiently. Given how many electronics there are in modern vehicles, this really is a crucial skill. I'm Haddo. Keep training. Thanks for watching.